Q2.1. The problem states that Alex and Shruti are playing Yahtzee, a game involving rolling 5 dice. In part A, we're asked to first define a probability space representing the possible outcome of Alex or Shruti's rolls of the 5 dice, and assume all dice are fair and labeled 1 through 6. So we're asked to define a probability space, which means we need to do two things. We first need to define an outcome space, and then the probability distribution of that outcome space. So for our outcome space, omega, that is just all 5-digit numbers with digits between 1 and 6. If you think about it, every player rolls 5 dice, and each roll can be a number between 1 through 6. And if we think about the probability distribution, well, there's no reason why one outcome should have a higher probability than another. So our probability distribution is uniform, which means the probability of any outcome in our outcome space is going to be equal to 1 divided by the total number of outcomes. And how many outcomes do we have? Well, omega is the set of all 5-digit numbers with digits between 1 and 6. So in every digit, we have 6 choices. So we get 6 to the 5 possible outcomes. So the probability of any outcome is just 1 over 6 to the 5th. Okay, let's look at part B. Part B asks, what's the chance that Shruti rolls a higher number on the first roll? Okay, so if we think about it, there's really 3 possibilities that can happen on the first roll. Either Shruti rolls higher, or Alex rolls higher, or Alex and Shruti roll equal. They tie. If we think about it, the probability that Shruti rolls higher on the first roll is equal to the probability that Alex rolls higher on the first roll. Because there's no reason Shruti should, the probability should be different for Shruti than Alex. So what we're going to do is we're going to let A denote the event that Shruti rolls higher on the first roll. We know that either Shruti rolls higher, Alex rolls higher, or they tie on the first roll. And then we're going to let B denote the event that Shruti and Alex tie on the first roll. So what we know is that in any case, one of these 3 events happens. So we know that 1 is equal to 2 times the probability of A, which is the probability that Shruti rolls higher or Alex rolls higher, plus the probability of B, which is the probability that they tie. And rearranging these terms, we get that the probability of A is equal to 1 minus the probability of B divided by 2. So now we just need to find the probability of B, the probability that Shruti and Alex tie. So there's 6 different numbers they can roll, and hence 6 different ways that Shruti and Alex can tie. And then there's 36 possibilities, because there's 6 possibilities for Alex and 6 for Shruti, and we multiply them to get 36. Which means the probability of B is 6 over 36, which is 1/6. And we can plug this in to find the probability of A, which is just 5 over 12. Okay, now let's look at part C, which asks, what's the chance that Shruti goes first? This is really just a question of symmetry, because if we think about it, Shruti has to go first, or else Alex has to go first. And there's no reason why the probability that Shruti goes first is greater than the probability that Alex goes first. Which means the probability that Shruti goes first is just 1 over 2. Okay, let's look at D. So D says, D basically asks us, what's the probability of rolling exactly 3 of the same number, or 3 of a kind? If we really think about this, there's 6 different kinds. There's 1, 2, 3, 4, 5, 6, just the numbers on our die. So let's just look at the probability of rolling exactly 3 of 1. We're going to let A denote this event. And if we think about this, This is really just an example of the binomial distribution, right? Because either, on every roll, I either roll 1 or I don't roll 1. So I know in exactly 3 positions, I need a 1. So I can essentially, so the probability of rolling a 1 on any roll is 1/6. So I cube that. And then I know in exactly 2 rolls, I need to not roll 1. And the probability of doing that is 5/6 for any given roll. So that's 5/6 times 5/6. And then if we think about it, well, I need to choose 3 rolls out of my 5 rolls to be a 1. And there's 5 choose 3 ways to do that. So I get that the probability of A is 5 choose 3 times 1/6 to the third times 5/6 squared. And then we know there's 6 different kinds of numbers we can roll, so we multiply this by 6. So the probability of rolling 3 of a kind is 6 times 5 choose 3 times 1/6 to the third times 5/6 squared. Okay, let's look at part 2. Question 2 is analogous to question 1, except everywhere we have a 3, we just replace it with the 4. So it's the same idea of using a binomial distribution where we have 2 potential outcomes on every roll, either that kind or not of that kind. And so what we'll get is 6 times 1/6 to 6 times 5 choose 4 times 1/6 to the fourth times 5/6. And we can express this very nicely to get 6 times 1/6 to the third times 5/6 squared. Okay, and then part 3 asks us which one is more likely, 3 of a kind or 4 of a kind. Well, if we look at the way we've arranged these, right, we can see that the probability of 3 of a kind is actually just 5 choose 3 times greater than the probability of 4 of a kind. And 5 choose 3 is greater than 1, right? Which basically means the probability of getting 3 of a kind is greater than the probability of 4 of a kind. And intuitively that makes sense because it seems like it would be easier to roll 3 of a kind than 4 of a kind. Okay, thanks for watching.